Hey, what's up? We're going to look at how we prove solutions are true solutions to a system of inequalities. So we graphed these beautiful things, right? We have our solution set, so now we're going to pick points and just verify that we actually graphed it correctly. We've looked at our calculator, and now we're going to mathematically prove that we are correct, right? When I choose a point, we're going to choose a point that's somewhere in our shaded region. I always like to choose points that might be easy to use. So I always look like, can I use the origin? Always start with 0, 0, because 0 is awesome to multiply with, right? If not, I try and look, is there another 0 point that I could use? So on number 1, I'm going to choose the point, let's just say, make sure we're nice and solid in there. So I'm going to do 0, and I'm going to do 1, 2, 3. Let's do 0, negative 3, right? So I'm going to do 0, negative 3, and I have to plug that into both of the inequalities for number 1. All right, so I'm going to take, remember this is my x, this is my y, and I plug in. So where y is now negative 3 is less than or equal to 2 times x is now 0. Notice I substituted into parentheses. And now we're just going to see, is this a true statement? So negative 3 is less than or equal to 2 times 0 is 0 plus 1. So negative 3 is less than or equal to 1. That is a true statement. Sweet. Okay. And we have to verify that it works for the other. Remember, a solution to the system has to be true for both. So I plug in negative 3 for y is less than negative 1/3 times 0 minus 2. Negative 3 is less than negative 1/3 times 0 is 0 minus 2. I have negative 3 is less than negative 2. That is a true statement. Sweet. Okay, so our solution set is in a good place. All right, let's look at what example B was. So here was our solution set. So the origin isn't in there. All right, but I can go up this y-axis and I could choose like 0, 5 right there. So I'm going to choose 0, 5 as my point. Again, you could choose any point in there, but you don't want to choose a crazy number that makes it really difficult for you. Okay, so now let's prove that this works for both points. All right, so wherever x is 0, wherever y is 5. So 3 in parentheses times 0 plus y is now 5 is greater than 2. All right, so 0 times 3 is 0 plus 5 is greater than 2. 5 is greater than 2. Yay! All right, over here we have x and y. All right, but we only have x, so I just plug in the x value. 0 is less than or equal to 2. 0 is less than 2. That's true. Woohoo! All right, our solution set is all right. Okay, let's look at C. We have this big spot right here, and I'm looking 0, 0. 0, 0 is in there. Okay, awesome. 0, 0 would be in my solution, so let's go ahead and choose 0, 0. All right, so remember x and y, we're going to plug that in. So negative 4 times x is 0, minus 5 times 0 should be less than 20. So this is 0 minus 0 is less than 20. 0 is less than 20. Woohoo! Works there. All right, again, we're going to plug it in to the second inequality because it has to work for both. So negative 4 times 0 plus 0 should be less than or equal to 0. All right, so we have 0 plus 0 is less than or equal to 0. 0 is not less than 0, but 0 is equal to 0. Woohoo! It worked. Okay, so that's all that you're doing. Pick a point. So let's look at D. Pick a point. Origin's not there, but I can go down here. Let's do 0, negative 5. We'll use that point. So 0, negative 5. 0, negative 5. All right, so x and y, substitute in. This one only has y, so I put in negative 5 is less than or equal to negative 3. Yep, negative 5 is less than negative 3. It's further left on our number line. That's a true statement. All right, over here, plug in. Y is negative 5, so y is negative 5 is less than 1/2 of 0 minus 1. Negative 5 is less than 1/2 times 0 is 0, minus 1. Negative 5 is less than negative 1. That is also a true statement. Woohoo! All right, so that is how you check mathematically. You take a point that's in your solution set for both, plug it in, substitute the values. It should be true statements for both of them. If it doesn't, oh, red flag, something went wrong.